Hey, hey, everybody get your apps and Zerts? Do they have Zerts out yet? Too early? Any other Parks and Rec fans out there? Yeah. Out in the mezzanine? Any Parks and Rec fans up there? Yeah. Okay. I'm a huge fan of the TV show Parks and Rec, and there's so much to love about the show, but one of my favorite things is Ron Swanson. So this is Ron. Now, if you're not familiar with the show, Ron's kind of an old school guy. He's pretty set in his ways, and he likes to stay off the grid. Now, in season 6, Ron discovers Yelp, and he thinks Yelp is amazing. He loves the idea of being able to review places that he's been. But Yelp is way too on the grid for Ron, so he picks up his typewriter under his desk, puts it on his desk, and starts hand typing out reviews that he intends to snail mail to places that he's been. Now, Ron writes some pretty amazing reviews. Let me read you one of them. Dear frozen yogurt, you are the celery of desserts. Be ice cream or be nothing. 0 stars. Now, I love Ron, and I love his plan, but I think there are a few key problems in this plan. First, snail mail is way slower than posting the review to Yelp, where it will be instantly available. The business he's reviewing may never actually open the review, and no one else is going to be able to benefit from his review. So while Ron was able to kind of get the feeling of Yelp, get a grasp for the technology, he didn't really change his mindset, and so he wasn't able to really get the full benefit of Yelp. And that's sometimes what we see when people move from SQL to NoSQL. They kind of see the benefits, but they bring with them their old mindset, their SQL way of doing things, and they don't get the full value of the technology. So that's what we're going to be talking about today, is how you can get the full value as you move to MongoDB. Hey, AV team, would it be possible to get my speaker notes on this machine? So let me take a minute and just introduce myself. My name is Lauren Schaefer, and as Amy said, I'm a developer advocate here at MongoDB. I spent the first 8 years of my career as a software engineer at IBM. And it was a great experience for me because I got to experience very different parts of the software development lifecycle. So I did Java development, web development. I spent a year as a test automation specialist. I did growth hacking engineering for a year, and I even did a little social media on the side. So after 8 years as a software engineer at IBM, I moved on and I was a developer advocate at Sugar CRM. And this last November, I came on to MongoDB. So for most of my career, I spent my life in the SQL world, probably like many of you. I took a database class in college, and we learned all about how to normalize our data, specifically for relational databases. We spent a lot of time learning how to draw big, complex ER diagrams. And I brought all that knowledge with me at IBM, where I spent most of my career in DB2. Now, at the end of my career, at time at IBM, we were starting to use NoSQL databases, but I didn't really shift my way of thinking, and honestly, I didn't get the full value out of it. So when I joined MongoDB, I had to really start shifting the way I was thinking, and so I'm excited to share with you what I've learned and really bring you on that journey with me. So today, we're going to be talking about moving from SQL to NoSQL. And I thought SQL to NoSQL was kind of a cute title, but let's be real, we're at a MongoDB conference, so we're going to be talking about how to move from SQL to MongoDB. Hey, Nancy, would it be possible, I can't see my slides up here, would it be possible to get them up on this screen? I'm sorry, I keep walking back all the way over here. Thank you. So if you're in this talk, I'm going to assume that you have some experience with MongoDB or no experience with MongoDB. This is an entry-level talk. And I'm also going to assume that you have experience with SQL databases, because we're going to use that as our baseline knowledge. So let's jump on in. Let's talk about how to take that leap from SQL to MongoDB. So we're going to start out, talk about how to map terms and concepts between the two. Then we're going to talk about the 4 humongous advantages of MongoDB. And then we're going to talk about how you can change your mindset in 3 key ways. All right, so let's jump right in with mapping terms and concepts. So I was lucky enough to go speak at the MongoDB.local in Dallas earlier this year. And my parents live in Dallas, so Texas feels a little bit like my home away from home. And so I went to the conference and I spoke there. And I went home and I had dinner with my family. And my dad, he's so proud of me with my new job, and he's trying to take an interest. And he's like, so Lauren, I was browsing the MongoDB website, and they kept talking about how MongoDB stores data in documents. Are they talking about Word documents? Okay, so no, we're not talking about Word documents, if you're wondering that as well. We are talking about JSON documents. So JSON stands for JavaScript Object Notation. So if you're a developer, you're probably familiar with JSON documents, but let's just give it a quick refresher and get everybody on the same page. So JSON documents all start and end with curly braces. On the left side, you have fields, and on the right side, you have field values. Now, there are a variety of types you can use for your field values, so let me walk you through what you're seeing here on the screen. At the top, we've got strings. We can have numbers, things like integers, doubles, longs, and decimals. We can have arrays. In this case, we have an array of decimals, and we're storing geolocation data. One of the really cool things about MongoDB is that they've got some cool ways to visualize your geolocation data built in, so you're not having to manually create maps yourself. So I don't have time to show them to you right now, but if you go down to the Compass booth or the Charts booth, they would love to show you a really nice visualization of geolocation data. So here you've got an array of decimals. You can have an array of any type, so an array of strings, or even an array of documents. There are a variety of other types, things like objects, booleans, dates, and timestamps, and others. So you've got a lot of flexibility in how you model your data. When people talk about MongoDB, they'll often use the term non-relational, but that doesn't mean we don't store relationships. Actually, we just do it in a different way. So let's walk through an example of how you would model this data on the left in SQL tables on the right. So up at the top, we've got information about our user. So as you can see here, our field names on the left map roughly to our column names up on the right. So we've got a table for users, and then we've got fields and columns for first name, surname, cell, and city. Now in our document, we're able to use an array stored in a single field. In SQL, we don't have arrays, so we're going to split that into location X and location Y. Next up, we've got profession data. Now a user could have 0 professions if they're a kid, or a user could have 100 professions if they're a job-hopping millennial. So we've got a 0 to many relationship. You've got an array you can use in MongoDB, which gives you a lot of flexibility. You can make it as small or as big as you'd like. In SQL, we're going to probably break that out into a separate table when we've got a 0 to many relationship. So as you can see, we've got a row for each profession, and the professions.userid maps up to our users.id field. Everybody with me? Yeah? Okay. So cars is very similar. It's a 0 to many relationship. So we're going to create a separate table for our cars and store it there. Again, the cars.userid field maps up to our users.id field. So we store documents together in what we call collections, just like you would store a group of rows together in a table. So collections and tables map roughly to each other. So I've put a couple of different documents up on the screen. Let's walk through what those are. So first up, I created a document for myself. I'm definitely not self-centered. And here we go. We'll get there. You'll notice that it's very similar to the Paul document we were just walking through, but it's a little different. So I've got mostly the same fields, but I'm missing a field for location. I'm a pretty private person. I don't want people knowing where I am. And then I'm also missing car data. And in MongoDB, that's totally fine. You can just omit the field. In SQL, if we want to represent this, we're going to have null values in our table, which is okay, but a lot of people discourage you from including null values. We've got another document here for my daughter, Sydney. Now, she's a kid, so she's going to not have a lot of the same data as Paul. So she's not going to have any profession data or any car data. She's my kid, so I don't want her sharing her location either. But since she's a kid, we've got an extra piece of data we want to store about here. We want to know about her school. Okay, so what are we going to do? Well, in MongoDB, we can simply add a field for school. What are we going to do in SQL? Well, we're either going to add an extra column to our table, or we're going to create a new table for specifically storing school information. either way, you're going to have to go talk to your DBA, right? And you're probably going to have to do a little bribing to get them to do that. Maybe you're going to bring some donuts. Maybe if they're very health conscious, you're going to bring them a kale smoothie, whatever they're into. Maybe you're going to bring your manager to grease the wheels. But you got to figure out how to get your DBA to store this new piece of information. If they agree to do it, you're going to look at possibly having a little application downtime, maybe some performance issues. So it's definitely doable. It's just a little messier. Now, I have a feeling some of you are freaking out a little bit because you're looking at these documents and they all have different shapes. They don't all have the same fields. And you've heard that MongoDB is a schemaless database and you're like, oh my gosh, how am I going to know what's in my database? So don't panic. MongoDB has schema validation and we encourage you to use it. So once you get your app up and running, you're feeling comfortable with your schema, you can add your schema validation rules in. And these schema validation rules are really handy because they give you a lot of flexibility. You can choose to throw an error, or you can choose to simply throw a warning. You can choose whether the schema validation rules should apply only to new documents or documents that are updated. So you get a lot of flexibility when you apply those rules. All right, so now we're kind of getting the idea of how things work in MongoDB. Let's do some very explicit term mapping. So on the left, I'm going to show you terms from MongoDB, and on the right, I'm going to show you terms from SQL. So we already talked about this one, right? A document maps to a row, or depending on how you've normalized your data, it can map to multiple rows. A field maps to a column, and a collection maps to a table. Now, these next few terms should feel pretty comfortable to you because they're going to be the same in both. So the term database translates pretty well. A database is a group of collections, just like a database is a group of tables in SQL. Indexes are pretty much the same. Views are pretty much the same. Now, joins are where things get a little different. In general, the general rule is if you've got data that you would typically split up among different tables, we want you to embed it. So the rule of thumb you're going to hear me say a bajillion times today, and you'll probably hear other people say it, is that data that is accessed together should be stored together. So if you're going to be accessing this information that you would typically split up at the same time, you want to just embed it in a single document. So in general, I want embedding to be your default go-to. But in some cases, it might make sense to store related information in separate documents, separate collections, or separate databases. So I'm not going to get into the details of how to do this, but basically you can create a reference from one document to another, very similar to how you would use foreign keys in SQL. Another option is to use $lookup. Now you can use $lookup when you use the aggregation pipeline. Is anybody here familiar with MongoDB University? A few people? Okay, let me give it a plug. So MongoDB University is the best way to learn MongoDB. It's free online learning, but you're learning MongoDB from the people of MongoDB. And MongoDB University is so good, it's actually how we train all of our technical employees. We all take these courses. They're fantastic, and it's free. So go take the MongoDB aggregation pipeline course. It's going to change the way you work with your data. The aggregation pipeline is super powerful. So go look up, go find the details on $lookup. They're going to go into way more detail than I have time to go to here. But just know if you want to do a left out or join, you can use $lookup. All right, so now let's talk about what you would need to do if you wanted to model an organization chart. So you want to say, these 3 employees report to this manager, and this manager reports to this executive. You're going to use $graph lookup, just like you would use recursive common table expressions in SQL. All right, one final term to map for you, transactions. Now, if you did your homework before you came here today, maybe you did a little Googling and you said, what's the advantages of SQL versus NoSQL? Or what's the best use case? You know, when would you use one versus the other? What are the pros and the cons? And one of the things that you will read over and over is that NoSQL databases do not support transactions, do not support ACID transactions. And if you care about data integrity, that's probably going to freak you out, right? Like, who doesn't care about their data integrity? So I want you to know MongoDB, beginning in 4.0, does support transactions. And as Grigori just talked about earlier on this stage, in 4.2, we added support for distributed transactions across sharded clusters. So We've got support for transactions. You don't have to worry. We've got you covered. Now I'm going to come back to this again at the end of the presentation and talk about why I don't necessarily want you to use them. So I'm going to put a pin in this, and we're going to come back to it. But with that, we're going to wrap up our term mapping summary. Now, a speaking coach would say, Lauren, do not create a slide like this. It's way too busy. And I agree. So I created this as a reference for you. Feel free to take a picture of it. You can, hashtag it MDBLocal. You can tag me. I'm Lauren_Schaefer. Yes, I will shamelessly plug myself. And then the slides are also available on my Twitter page and will be made available after this presentation. So I created this as a reference for you for later. But what I want you to know right now to get through the rest of this presentation as well as the rest of the day, it's the first three. So let's refresh on those. A document maps to a row, a field maps to a column, and a collection maps to a table. All right? All right, so now we're kind of on the same page. We've got our baseline knowledge. Let's talk about the 4 humongous advantages of MongoDB. All right, so here's your trivia for the day. Who knows why I'm using the word humongous? Anybody? Mongo came from it, yes. So the word Mongo of MongoDB comes from the word humongous because we are amazing at storing humongous amounts of data. So let's go back to Ron. Ron loves his typewriter. And until we can convince him why using this new technology is better, why he needs to change his mindset, he's not going to. So I want to take a minute and explain to you some of the benefits of changing your mindset and switching to MongoDB. So the first 3 I'm going to move through quickly, and the last one I've got a code example, which I think is going to be pretty exciting. So here they are in no particular order. First up, you can scale cheaper. So as the size of your base grows, you can actually scale horizontally. Okay, what do I mean by that? So let's say you've got a MongoDB server. You've got a green server on the left. And you've got your application running. Things are going well. But your application starts to go viral. And you fill up your server. What are you going to do? In MongoDB, you can shard your collection, which means basically to split it, and add an additional server. Now, this new server doesn't have to be big and huge and expensive. It can be a cheaper commodity server. Now, let's say Kim Kardashian tweets about your app, and it blows up. What do? Well, you can continue sharding, add another server. And again, this can be a cheap commodity server. All right, let's talk about the SQL world. What happens? You've got your database running. You start running out of space as your app blows up. What do? You've got to typically, you're going to migrate to a bigger server. The problem here is that bigger servers are not necessarily the same cost as having 2 smaller servers, right? The bigger the server, typically the more expensive it is. So now Kylie Jenner tweets about your app in a good way, and it blows up. What happens? You've got to migrate to an even bigger server. A few problems here, right? It could be prohibitively cost expensive. There could be, if you've got a cloud provider, they might be like, look, you've got the biggest server we've got. If you've got a physical server, a bigger server just may not exist. The other problem here is you may have application downtime as you're migrating to this bigger server. So being able to scale horizontally can be a big advantage. Next, you can query faster. So you can stop doing expensive joins to get your data. So remember my rule of thumb here? Data that is accessed together should be stored together. And if you're doing that, when you go to run a query, you get your document, and you're out. Or you go get your group of documents, and you're out. What's happening in SQL? You're going to go get information from different tables and pull it together. And depending on how much data you've got to pull together, those joins can get really expensive really quickly. You can pivot faster. You can easily change the shape of your data as your app evolves. So let's say I started programming my application and I've got a document like this. And things are moving along, but someone comes and reviews my code and they're like, Lauren, what were you thinking? Why would you store the number 1 as a string? That's craziness. That should be an integer. Okay, so we need to change the type of this field. Okay. And now, you know what? Our requirements have changed because requirements always change, right? And we no longer need to store field E, but we need to add a new field. What are we going to do? In MongoDB, you can simply start storing information the way you want it. Now, if you've got your schema validation rules in place, you can adjust those, and you've got a flexibility in how you apply those schema validation rules. So we're moving on. Okay, in SQL, what are we going to do if we need to change the type of a field, and we need to add a new column. We're looking at an alter table. And you guys know how fun those are, right? Sometimes there's downtime, sometimes there's performance implications. It's doable, it's just not quite as simple. All right, this last one I really, really like. So with MongoDB, you can program faster. And that's because documents map to data structures in most popular programming languages. So to be honest with you guys, when you become a developer advocate at MongoDB, they give you the default stuff you're supposed to say, and this is one of those things that we say over and over. And I was like, okay, whatever, it's probably not that big of a difference. But I said it anyway. Okay, so then somebody, when I was preparing this presentation, said, Lauren, you should really code up an example and see the differences. And so I did, and to be honest with you, I was shocked. So I'm going to walk you through the differences in programming between MongoDB and MySQL. So let's take a look. So what I decided to do was program up a user profile page so I could use that same data structure I was using at the beginning of the presentation. So I've got a user profile page. I'm storing their first name, last name, cell, city, location, and their profession. All I did was decide to skip that car data because it doesn't really belong in a user's profile. So just to remind you what our data structures look like, we've got a single document from MongoDB, and in SQL we've got two tables because remember I pulled out that car data. So we've got a users table and a professions table. So I wrote a Python script to allow users to update their profile page. So let me walk you through what that looks like. So on the left, we're going to have MongoDB code, and on the right, we're going to have SQL code. So at the top of this file, I've got your basic top of file stuff, right? Your imports, your connecting the database, and your variable declarations. Now if you look down, I've set user ID to 1. In a real system, you'd be dynamically pulling that out of the session data, but it doesn't really make a difference in our comparison, so I just hard-coded it. Let's take a look at our MySQL code. Pretty much the same here, right? We've got our imports, we're connecting to the database, we're hard-coding that user ID value. All right, so now let's go and retrieve the information from our database. Here's where we start to see differences. We're going to go and we're going to get the user's profile information. So we can pull all of the information from the same document since we used embedding. So I've got a query here. I'm saying access my database, the user's collection in it, find one document where the ID is equal to the user ID. And we're done. And so here's where that advantage comes in. Documents map to data structures in most popular programming languages. So my results come back for me as a Python dictionary. I don't have to do anything to translate these results. I'm good to go. Let's take a look at MySQL. So we want to do basically the same thing. So first thing we're going to do is get everything out of our users table. So I've got a query here. It says select everything from the users table where users.id is equal to my string. I'm using prepared statements, keeping everything nice and safe. I'm setting my values. I'm executing my function, and then getting my results. Now, unfortunately, these results don't come back nice and clean in a Python dictionary for me. So I've got to create that myself. So I've got user equal to curly brace, first name equal to result 1, surname equal to result 2, all the way down. Is this that complicated? Admittedly, no, this is not that complicated. But I did not actually write any unit tests, so I have no idea if I screwed this up and got something in the wrong order. And let's be real, if you guys were peer reviewing this, you were taking a look at my code, you would also have no idea if I had messed up here, right? It's very easy to introduce simple bugs. So I've got the information from my users table. Now I need to go get it from my professions table. So very similar. Go get everything from the professions table where professions.userid is equal to my string, set my values, execute it, fetch my results. Now what I want to do is create an array of the professions. So I create an empty array. I loop through my results, append the result to my array, and then I stick that professions array into my user Python dictionary. Okay, so now I'm in the same spot. All that code, but I've got two Python dictionaries, one in each code script, set user Python dictionary. Okay, so now I've pulled the information. I need to update it. So what I do in a real system here is I would pull the information out of the web page. It doesn't really impact my comparison here, so I'm just going to hard code it. So I'm going to just say first name is equal to new first, surname is equal to new surname, all the way through. I'm going to do the same thing on the MySQL side. If you're looking at real closely, you'll see there is a line difference, and that's just in the locations. So in the MongoDB side, I left it as an array. In the MySQL side, I split it up into location X and location Y just to match my columns. Okay, so I've retrieved my data, I've updated it, now I need to push it back to my database. So let's take a look in MongoDB. Since the user's data is stored in a single document, we only have to make one update. So here's my query. I'm going to say, in my database, access the user's collection, update one document where the ID is equal to the user ID, and then I'm going to do a set, which is basically going to push everything inside of my user dictionary. And I'm done, nice and clean. Okay, now let's talk about MySQL. I've got to make updates into tables. So there are a few ways you could do this. I decided just to do two separate queries. So we're going to say, update the users table, set first name equal to this string, surname equal to this string, all the way down where ID is equal to this string. And then I'm going to list my values, execute the query, and commit it. Again, this is not that complicated. This is a pretty simple query, but it's very easy to make mistakes in here. And I have a feeling many of you have written some huge queries where this has gotten very messy very quickly. Now I need to update my professions table. A few ways you could do this. I decided the easiest way for simplicity was just to go in and delete everything in the professions table for this particular user, and then do an insert for all the new data. So I say delete from the professions table where the user ID is equal to this string, get everything out, commit it, and then I'm going to loop through my professions array and do an insert for every single profession. Now, I wrote a lot less code on the MongoDB side, right? If we take a look, I counted my lines of code. We'll get there. I had 30 lines of code in MongoDB and 73 lines of code in the MySQL side. That's like a 1-to-2 ratio, which is crazy. And if we pull out some of that similar boilerplate code, the ratio gets even bigger. Now, fewer lines of code is not always, indicative of better code or simplicity. But in this case, I think we can see that there are fewer opportunities for introducing bugs. And it was faster to write, which is really, really nice. So with MongoDB, you really can program faster. All right, so now we've talked about the big advantages of MongoDB. Let's talk about the 3 key ways that you need to change your mindset. Because let's go back to Ron, right? Ron got so frustrated, he just threw out his computer one day, okay? So people who pick up MongoDB and try to use it as a relational database are the ones who struggle and sometimes fail. And I don't want that to happen to you. I want you to be successful. So let's talk about 3 ways to change your mindset in no particular order. So first up, embrace document diversity. Is anybody in here familiar with the Gang of 4 book, the design patterns? Yeah, okay, yes. Okay, so in MongoDB we talk a lot about having schema design patterns, kind of a similar idea. So there are 2 schema design patterns that really embrace document diversity. So first up, we've got the polymorphic pattern. These are the same documents I showed you earlier, Paul, Lauren, and Sydney. And as you can see, they've got different fields for inside of each document. So when all documents in a collection are of similar but not identical structure, we call this the polymorphic pattern. You use this pattern when you want to be able to query across information that is similar in nature from a single collection. So in this case, maybe we want to write queries so that we can search by first name and last name and just retrieve the information about them. That would be a great use case for the polymorphic pattern. So even though these documents do not all have the same fields, it's okay. We're leveraging the polymorphic pattern. All right, one more pattern for you, the outlier pattern. Let's say that we wanted to model Twitter data. You might model it something like this. Okay, here's my handle. Again, I'll plug myself. Feel free to follow me. At the top, I've got my ID as my handle. I've got a display name, a number of followers, and a list of followers. There's a potential problem here, though. If I become wildly popular because you all follow me, I might exceed the MongoDB document size limit of 16 megabytes. And so it's do we want to model our data for the most popular use case, our common use case, optimize for that? Or do we want to optimize for the outlier use case? Well, really, we can optimize for both. So in most cases, we might model our data something like this. Let's take a look at Nick Offerman. He is the character who plays Ron Swanson on Parks and Rec. So his document looks very similar to mine. He's got an ID, a display name, a number of followers, and a list of followers. But when his list of followers gets too large, when we start to say, okay, we're approaching that document size limit, we can add a new field, name it anything we want, like has extras, and set it to true. Then we can create another document for him. Looks very similar to the original. We've got a new field, is overflow, set to true, and we start listing out the rest of his followers. And if he continues to get more followers, we can create another document for him. So we've got a lot of flexibility in how we model our data. You're able to optimize for the typical use case, but still allow for those rare outlier use cases. Okay, so embrace document diversity. Second way to change your mindset. It's my rule of thumb. I've been saying it all day. Data that is accessed together should be stored together. The thing, though, is that you've probably heard over and over again that you should normalize your data, right? It's been ingrained in us. So let's talk about why that is. Well, when relational databases became popular, disk space was extremely expensive. Financially, it made sense to normalize your data. So as you can see from this chart, and you know from buying flash drives, right, disk space has gotten a lot cheaper. Our phones, tablets, laptops, and flash drives have more storage capacity today than they did even 5 to 10 years ago. So what we've seen is a shift in development costs. It used to be that storage was expensive and developers were cheap. And now, storage is cheap. I promise there's a blue line there, you can't see it. And developers are expensive. So we want to optimize for developers and their time. Right? Developers don't want to be bogged down in data storage specifics. I know I don't. Like, I want to focus on the high priority stuff, the stuff that's going to move my career forward, that's going to make business impact. I want to be focused on that business logic. So what we want to do is optimize for developer time. So it's going to be a lot easier as you're programming if you don't break up your data, right? Don't normalize your data for the sake of normalizing it. Instead, leverage embedding. Consider how you can use subdocuments, arrays, and arrays of subdocuments to store your data together. Resist the temptation to break your data up just to break it up. Remember, data that is accessed together should be stored together. If you end up repeating data in your database, that's okay. And I know it's going to feel horrible the first time you do it. You're going to be like, oh my gosh, I should not be repeating data in my database. But remember, storage is cheap. So if you're not going to be updating the data very often, it's totally fine to repeat it. All right. Last way to change your mindset. Tread carefully with transactions. And it's not because transactions don't work well. Our engineering team has done a fabulous job implementing transactions. They work really well. The problem is that relying on transactions can be a bad design smell. So this really builds on the first two ways to change your mindset. So remember, not all documents need to have the same fields in the same collection. So perhaps you're using a transaction because you've chosen to split your data because the fields are not identical. Well, maybe it's better to group it together into a single document. Remember, data that is accessed together should be stored together. So if you find yourself using transactions really frequently, consider if you need to remodel your data. All right, so let's wrap this up. Let's recap what we talked about today. So today we made the leap from SQL to MongoDB, right? We started out by mapping our terms and concepts, and I don't want you to forget those first three. So a document maps to a row, a field maps to a column, and a collection maps to a table. Then we talked about the 4 humongous advantages of MongoDB. You can scale cheaper because you can scale horizontally. You can query faster because you're not having to do expensive joins to bring your data together. You can pivot easier because you've got a lot of flexibility in your data modeling. And finally, you can program faster, right? That example was crazy, that 1 to 2 ratio. So, and then finally, we wrapped up by talking about how you need to change your mindset in 3 key ways. So we said, embrace document diversity. It's okay if not all documents in a collection have the same fields. Data that is accessed together should be stored together. And then tread carefully with transactions, not because they don't work, but because it might mean that you need to remodel your data. All right, so let's wrap this up. If I had to wrap this up in one slide, I would say, don't be Ron Swanson in this particular case, because Ron Swanson is amazing. But in this case, don't be Ron Swanson, change your mindset, and get the full value of MongoDB. All right, so the slides are available on my Twitter page, so I've added some links at the back to give you some additional resources. So I want to plug the MongoDB University course on data modeling. It's brand new. It was released this summer. It's a fantastic course. Go check it out, sign up. It's going to save you a lot of time and headaches if you model your data correctly the first time. I've got some links to some other additional resources. And then again, I would love to connect with you. I'll be hanging out at the Atlas booth during lunch, and I'll be around the rest of the day. I would love to chat with you, answer any questions you have. So thank you so much for coming. Enjoy the rest of the .local. Thank you.